All right, hi there. So again, we have our video notes. Remember, we're using these for when you're absent, if you go on vacation, or if you just need a little bit of a review. Always a great thing to have is doing it alongside in the video. So this is our learning target 1.3 function composition. Okay, so again, when we do the video notes, we don't do the warm-ups. Those are for in class. So let's move on right to the notes. So it says for function composition. So we've already combined functions with arithmetic operations. That was 1.2 when we were adding, subtracting, multiplying, and dividing. So now we're going to look at another method used to combine functions, and that's called composition of functions. So in a composition of functions, the results of one function are used to evaluate a second function. And I do this a little bit differently, so I'm going to show you how to first combine and then use the number to evaluate. So we're going to then look at the next part, which is pretty important. We always evaluate the composition of functions. We go from right to left, which just means we use the inner function, the one on the letter on the inside, and we put that to the letter that's on the outside, meaning the one on the left. So like example here, up here, sometimes you see it written as this way, and then this one here, I'd like you to label it. You know how I like to color code. So this one is our outer function because it's the letter that's on the outside. And the inner function is the other letter. And again, we could write this first one is f of x, and we could write the second one as g of x. But you know, in math, we like to do shorthand. So this is how we come up with the function notation, how we write it. But again, the one on the outside is the outer function, and the one on the inside is the inner function. So we always take the inner function and we plug it into the outer function. That's basically what that last bullet point means. So we're going to look at evaluating a composition of functions. So we have two of them. I'm going to look at f here. This is my f of x. And this is my function, okay? If you notice here, this is my outer function. So we're going to be plugging something into this f function for our x. Now, remember, I said I like to do it a little bit differently. I like to first just combine the functions without this number here. So I don't even look at this number yet. I wait to the end to plug the two in. I actually combine the functions first. And it's multiplication. So we are a little familiar with already doing this, and that's why I like to do it that way. And then we have g, that's the inner function. Okay, so g is over here. This is our inner function, very small. Okay, so what we have to do is we are going to take our inner function, the g, and we are going to pop that in to the x for our f function. So I'm going to write the function for f. That's our outer function. We write that one first. 3, and then I'm going to leave a blank set of parentheses because that's where our x goes, plus 1. And remember, so with the composition of functions, what I like to do is I take this inner function, whatever g is, again, ignoring the number for now, we're going to use that at the end. We're going to plug the other function, the inner function, in here. So g goes in here as that x value. I plug in my inner function. I like to write that again, just so I know when I look back at my notes, what I'm doing is I'm taking the inner function and I'm plugging it in. So then I just put that. This is a small function, so it's just x to the third. Sometimes it's going to be, it could have 2 or 3 terms, but this one's just a little bit simpler. So now I'm going to do order of operations. So I'll just use a totally different color. This is 3 times x to the third. So it's just 3x to the third. And then this is behind the parentheses, so I just drop down the plus 1. Okay? So the next thing I do, now that I've combined them, There is no simplifying, no combining like terms. I'm done. So now I'm going to go back up and use my number. This is where I'm going to pop this in to the x now. So once I combined, I put my inner function into my outer function and just combined them. I looked for any combining like terms, and then I have a function I'm left with, and I'm just going to use the number for that. So it becomes 3 times 2 to the third, because that's the number we're going to use, and then I close the parenthesis, because I just plugged that in for my x, plus 1. So if you type all that in your calculator, you should get, and again, how we write it, function notation, we're just going to do f of g of 2 equals, our final answer would be 25. Just plugging it all in our calculator. Okay, so again, that's how I like to do it. There is a way where you can do it where you plug the number into the first one, you get a second number, and then you plug that second number into the second function, and then you get your answer. I personally think it's easier, and this is the way I will teach it, is we combine our functions first, and then we use the number. Okay, so this next one, it's written here like this. And so when we do the composition of functions, we're going to sometimes see it like this or like this. But again, what this would mean is for right now, so then this time g is going to be our outer function because it's on the outside, and then, or it's the first one we see, and this f is going to be our inner. So it helps to label these. Now I'm going to show you with B, I'm going to show you the other way we can do it. When we use the numbers and first, and then we get a number, and then we plug it into the next one. So the first thing I'm going to do here is I am going to plug in. So again, I start with my one on the inside, this f. Then I'm actually going to take the number 2 and plug it in. Okay, so f of x is 3 times x, which we're saying is 2, and then plus 1. So what I end up with is the number 7. That's what I got for f. I'll just put that off to the side here. Now, what happens is I have to now take this number, and I need to use this for my new x, and I go to my next, or my outer function. So that's this x to the third power. So I'm going to go to, instead of x to the third, I'm going to do 7 to the third. So that's for my g, and that's going to equal 343. So that's my answer there. So there were two ways we just did. One was where I ended up putting the inner function into the outer function and simplifying. And then I plugged my number in. The second way, what we did was we used our number and we plugged it into our inner first, and we got a new number. And then we went to our outer function and we plugged that new number in for the x, and we got an answer. So there's two ways to do it. The reason why I chose for B, the second method, is because I noticed it was an x to the third power that we were going to have to plug in. And that would mean if we plug that in, we're going to have some foiling to do. And when it's not just a square, when it's to the third power, it can get messy and be more work. So it was easier for me to choose the second method. Okay, so for C, I'll do it both ways for you. And then on the checkpoint, you can pick, again, when there is an x to the third power, if you have to plug that into something, it's always better to choose that second method where you're using the number and then getting a new number and then using that new number for x. All right, so let's look at C where it says, again, it's going to be the same thing, but this is our outer because it's on the outside. And again, this is our outer. So it actually wants us to multiply both functions by each other, where we have our f of 2 here. So the first way I would do it, so with f and f, so if I look at my function f, there is no cubed. It's just a 3x plus 1. So I can actually plug in, I would take my outer, 3 times, and then I can plug my f, my other function, into there. Again, it's the same function, so it's 3x plus 1. So I plugged in my f to my f, 3x, and then plus 1. So if you noticed, I have where I plugged this f into the f. That's the one where I'm not using this number 2 first. I'm going to do it at the end. I think it's easier when you don't have something cubed, it's a little bit easier to pick that method, but you can choose either one. All right, so now all I have to do is simplify, and then I'll plug the 2 in. So I got to make sure, we got distributive. So this becomes 3 times 3, so I get 9x plus 3, and then this is on the outside, so plus 1, so I end up with 9x plus 4. That's my simplified function when I multiply the f of x and f of x. So now I can use the 2. So I can do 9 times the 2 plus 4, and I get 18 plus 4. So I get 22. That's my final answer. So let me show you the other way. I'm going to give myself a little bit more room. So just putting a little paper here. So hopefully you can write a little smaller, or if you want to get another piece of paper, but I want to make sure I give you options. So this is the second method again. So the second method is I'm going to take this number and plug it into the inner one first. I go from the inside, meaning the left to the right, so the inner. So I go by pretending that 2 is my x, so I go to my inner function, which is 3 times x, which is, it tells us here it's 2, plus 1. So that's my inner, I'm doing my inner one first. Oh, that should have said inner, sorry about that. And then I simplify, so I get 6 plus 1, which equals 7. So 7 is my new number. This is the new number I'm going to be using. I can't go back to this 2. I'm using this new number of 7 to figure out the answer. So then I go to the outer function. It just happens to be the same one. My outer function again was 3 times x. Remember, my new x is 7. And then plus 1. So when I simplify that, that becomes 21 plus 2, so I get 22. So both ways are okay to do it. Some teachers prefer you do it this way, where you plug the number into the inner one, get a new number, and then you use that new number and you plug it in. I'm okay with combining them. Again, it's either way you choose. So right now I want you to, using the new functions they give you. So f, we'll call this one right here, it's 2x plus 3. And then g of x, well, we have a square root, so I'm going to use a different color. And it's the square root of x plus 2. So you can use either method, but again, it's going to be the same thing. You'll want to label. This is your inner. We always start with the inner going into the outer. Okay, if you want to, you can just automatically put g into f, because we've learned that in the last few sections, and simplify. Or this one might actually be easier since we've got a square root here. It might be easier to just use g, plug the 9 in, get a new number, and then you will use that new number and plug it into f. Okay, so choose either way you want, and I want you to go ahead and try those two, and then unpause it and check your work against mine. Okay, so as you can see, I did both ways on my practice. So the first way, I just took g, the inner, I took this g and I plugged it into the x value, and I got this as a I guess you would say, simplified function. So then I could just take the 9 and plug it in for x, and my calculator did the rest of the work, and I got 7. Or I use the second way where I use the number first for my inner. So I take that number, which is 9, and I plug it into the g first, and I got 5. And now I have to use the 5, and I'm going to plug it into my f, which is the outer, and I got 7. So it doesn't matter which way you go. You can use either way. So then again, so check number 2, you should have had 7. Here's my work. You can pause it if you want to look at it. But the same answer, just by coincidence, but the work should all be different. All right, so we're going to go to example 2. So now we are finding composite functions, but now there's no number. So this is more what we're looking at when we were doing 1.2b. When there's really no number, we're just plugging one into the other. So that's the method I showed you on the top part, so that we're already there. So let's look at, I'm going to call f is our outer, okay, and g will be our inner. Okay, so remember, when it's here, there's no number in here, so this is even shorter than the first part. So what we're going to do is we're going to take g and we're going to plug it into f, because that's what it's calling on us to do. So let's look here. I'm going to take my f, so 2, and then my x is whatever g is. We're using that. So is 1/2 x plus 3. It's all of those things. That's my inner. And then I'm going to finish f, which is plus 8. So I took my outer one and I plugged in g on the inside. So again, we work from the inside to the outside, or left to the right. Okay, so again, so now we just simplify. So I'm going to do distributive property. So that becomes 1x, or just x, plus 6. We're timesing by both. And then that plus 8's out on the end. Again, just write x, and then plus 14. And we are done. Okay, so that was a little bit easier when there's no number. Okay, so let's look at the next one. Things are switched up now. So g is now the outer, and f is the inner. So again, we start with our outer and we plug that inner into it. So the outer is 1/2 times x. So I'm going to leave a big parenthesis because I got to plug in my f, the whole thing. So that's that 2x plus 8. And then finish the rest of g, which is plus 3. So again, distributive property, multiply, so that becomes 1/2 times 2, so it becomes just x, or 1x, I'll keep it there, and then plus 4, 1/2 times 8 is 4, and then plus 3. So when we simplify this, this becomes, those can go together, x plus 7. Okay, and the last one, this is just for the easier ones when we don't have division in one of them. So we have f and f. So we're going to plug f into f. So this one, it really doesn't matter, inner, outer, but again, I just like to label it. That's our outer, this is our inner, and we have f. So f is over here. So 2 times, we got to just put this inner in there. It just happens to be the same one, 2x plus 8. And then we close the parenthesis and then plus 8. So I used I'll just color code it, this one here, 2x plus 8, our x was our other f. So again, we're going to distribute, so 2 times 2, we get 4x plus 16 plus 8. And so when we simplify 4x plus 24, simplest form. Okay. All right. So now let's look at the next example. We have one of them is actually a division problem or has a fraction bar. So it's a little bit different, but I still want to look at these. So again, same rules apply. There is no number in here. So we're just plugging the inner into the outer. So I'm going to use F, that color, and I'm going to go ahead and use G as this color. G is all of that. Okay, so this is saying our inner is G, and we're going to take that and we're going to plug it into our outer, which is F. So I'm going to start with F, 5, and then for that X, I have to plug in 5, and then I have to plug in what that G is. So it becomes, it's actually 2 over X minus 1, and then I would close my parenthesis. So I have to times those, and then plus 2. So I have to still have that. So if you remember, this is the tricky part. When you're multiplying fractions, we have to make sure that both numbers are fractions. It makes it a lot easier. So this is a whole number, so we're really going to call this just like 5 over 1. This isn't distributive property. This is actually just a fraction times a fraction. Multiply across the top, multiply across the bottom, and then we simplify. So 5 and then times 2, that would get me 10, and then 1 times, well, that's the same thing on the bottom. And then this plus 2 is just over here. We can't put anything else together. This isn't in the parenthesis, so this is actually as simplified as it gets. So when you see a problem like this is a fraction that we put in there. We have to multiply across the top, multiply across the bottom. That's why we made that 5 into a fraction. We can always put it over 1. Let's look at B. Again, this wants me to do, my outer is now G, and my inner is F. So I'm going to take this outer I'm going to take my inner and plug it into the outer. So I start by writing 2 over, and then that X, that's where I plug in my outer fraction. So that's 5x plus 2. And then that I'm going to put that whole quantity minus 1. Okay, so where there's no multiplication, if you notice on the bottom, it's just addition or subtraction. So we can actually combine like terms. So the 2 on the top is going to stay the same for now. But then 5x can't go with anything. But what about this 2 minus 1? So that actually becomes minus 1. And then this is as simplified as it gets. We just simplified because the positive 2 and the negative 1, that becomes just I'm sorry, that should be a positive 1. 2 and minus 1, so that's 1. Okay, so that's simplest form. And then the last one, we're going to plug our first one, F into F. So again, this is our outer, this is our inner. When it's the same, it makes it a little easier because there's no accidentally screwing up which one you put into there. You are just going to take your 5, and then for your X, you're plugging in your outer, which is just happens to be 5x plus 2. It's the same one. And then plus 2. So I wrote the whole thing. This was the X. I plugged it in. So now I just distribute and combine like terms. So that becomes 25x plus 10. This is on the outside, so plus 2. So I can combine these two, 25x, and then I have 10 and 2 plus 12, and I am done. Okay, so that is how we are going to find composite functions without the number there. We're just plugging them into each other. So I've turned the page, and you are going to try the checkpoint. Again, you have different functions, but your inner gets plugged into the outer. Okay, so this is your outer. new one. And then this could be, this is your inner. I'm going to put it up there. And this is G. So you're plugging this G into the F. And then for this one, you're plugging the F into the G. All right, so go ahead. I want you to pause the video and try this on your own, and then unpause it when you're ready to check your work. Okay, so hopefully those weren't too bad. The first one was a little more work because you had to distribute, but I plugged my G into my F, and then I had to distribute, so I got 3 times the square root of x plus 2. And then the last one, when you plugged them in, the x was underneath. Well, all of that is the x. So it's just the square root of the quantity. I should keep that parenthesis there. 3x minus 4, and that's all of my f. And then plus 2, and that's it. All right. So we are going to now move on to evaluating composite functions using tables. This one's a little bit easier. So this is where I'm going to color code it again, but we are going to use the tables. So we have G right here, G of x, and then I'll use the blue or teal or whatever, F. So for the first one, remember, we always go with the inner first. So I'm going to look at when the x value is 2. So I go up to my G table, and when x is 2, what that means is I have, so G would equal for that one, so G is going to equal 3. So now I have to take this and use that for my outer. So what that's really saying is f of 3, what is that? So it just means when in my F table, when x is 3, remember that's my x. So I go over here and look, when x is 3, what is my y or my f of x? It's 9. And that's it. That's our final answer for this f of g of 2. So let's look at the next one. Okay, it wants me to start. My inner is g of 1. So I'm going to again go where in my G table where my x value is 1, and that tells me, so G of 1 equals 9. Oops, that's an ugly 9. But I'm going to be using this 9 now. So the 9 then transfers to my F, because that's my outer. So F of 9, or when the x value is equal to 9, so I go to my x, what is my f of x or my y? So that's my x. And that tells me it's actually 6. That is my final answer. So 2 steps. All right, let's try C. Now we're doing the F first. This is on the inside, so F of 6. I'm going to my F table, and I'm going to look at when my x is 6. And I am going to find that f of x or the y value, just the corresponding one. So when that becomes f of 6 is actually equal to the number 7. I found 7 here. So now I'm going to take that 7 and I'm going into my G. So this becomes G of 7. That's the number I found. So again, when in the G table, when my x is 7, that is going to mean when it is 7, the answer is 4. So now what I need you to do, our answer is 4 here. Sorry, that's kind of messy. You are going to pause the video and do the checkpoint for me. Okay, so hopefully you have the same answers. And then for the next one, I have that f of 6, so I found f of 9, and then my final answer here is going to be 7 also. So we have our last part, which is can evaluate a composite function using graphs. So again, this is a little bit easier than plugging things in. We are going to look at first, again, we have to go by our rules where we plug in the function that's on the inner. So we do our inner first, and then we're going to look at that part and we'll find the outer with our new number. So we're going to do these together. We're the first one together, and then you'll try one. Okay, so I'm going to look at my G. That's this one here, the straight line, and I'm going to pretend my x is -1. So on the x-axis, I'm going to go to -1, and I'm just going to draw, remember, a vertical line. And I'm going to see, where does my G graph, which is this one, where does it hit at on there? So it hits right here, and it actually hits at -2 or -1, 0. So it G of -1, it actually hits at the number 0 right here. This is the ordered pair, -1, 0. That makes sense. So now I have to use this for my F. Now I have to find F, and I'm going to use this for my F. So my F of 0, so now I have to go again, and I'm going to make a vertical line at 0. 0's right here. It's the origin, my vertical line, and I'm going to look at my F graph this time. That's the parabola. So we have this one here. Where does it hit? Right here. So the ordered pair is actually, it becomes, we want when x is 0, so we're looking at where does it hit here, and it actually hits at 3. So it's 1, 3. So we're really, it's 0, 3. So we're looking at the number 3 as our final answer. All right, let's do one more practice piece. We're going to go the opposite way. So the first one, we want to know the F when it's when x is -2. So I'm going to go to this graph again. I'll just use a different color, maybe like a highlighter. So I'll do the F as -2. So I go to -2 and I draw a vertical line. And then I'm on my F graph only, which is this one. Okay, I look at where does it hit? It hits right here. So I'll just put in the yellow. So the F of -2, it hits at, I got to just count over, 1, 2, it hits at a +2. Okay, at this point, just to shorten the video a little bit, I want you to pause and try the checkpoint. Pretend you didn't see that. And go ahead and then unpause it to see if you have the matching answers. Okay, so hopefully you're understanding this. It's making sense. Now you're going to do the practice for 1.3.